Example 1. A simple truss is used to support a 4 kN load as shown in the figure. Determine the support reactions and the force in each member of the truss. First, you can solve it at C. So at joint C, we'll have our force 4 kN going down, and then we will have two forces. We have, this is force AC, and then we will have force BC, and our force BC has an angle phi from the horizontal. Now, in the previous video lecture on the discussion on how to do method of joints, there are two ways to know the sense of our forces in doing method of joints. One is by inspection and the other one is by assumption. So when we say by assumption, we immediately just assume that all of our forces in the structure is tensile, and if we ended up with a negative answer, then our assumption is wrong. On the other hand, when we say inspection, we will be assessing the given forces in the structure or the external load applied to our structure. For our case, that is 4 kN going down. So if we have a force going down, there must be a force going up to counteract the 4 kN going down in order to maintain equilibrium. Now for our two members, AC and BC, only BC has a vertical component, so therefore our BC is going up. So that's by inspection. Now upon inspection also, if BC is going up to the right, going up to the left, therefore there has to be a force going to the right to counteract the x component of our BC. So therefore AC is going to the right. Now before we proceed, we have to calculate also the value of our phi. Tangent phi is equal to, the opposite of angle phi is 2, the adjacent is 4, so therefore phi is equal to arc tan 2 over 4. So phi is equal to, you bring out your calculator, so that's shift tan 2 over 4, and that is 26.56. No, this is 5.65051177708 degrees. And of course, if you have to convert that to decimal degrees, you just press SD. Okay, now we can now solve for our BC, force BC and AC, having calculated our angle phi. So you'll use our equilibrium equation, that is summation of forces y is equal to 0, assuming going up positive. Now it is ideal that we start with our forces y. We do summation of forces y. It's because if the only given for at joint C is 4 kN in the vertical axis, so if we do force summation in the x, we will end up with two unknowns. So better yet, start with the coordinate axis where there is a given value. So for this case, this is assuming going up is positive. This is force BC, and that is sine phi minus 4 kilonewton is equal to 0. So force BC sine phi is equal to 4. Finding out FBC, this is 4 divided by sine of our angle 26.56501, no, 505117708 degrees. Therefore, force BC is equal to, this is 4 sine, no, it has to be degrees, sine answer. This is 8.944279191. Don't forget the unit, and don't forget to box your final answer. Having calculated BC, we can now solve for AC, which is summation of forces X is equal to 0, assuming to the right positive. This is force AC minus force BC, right? Yes, BC, and this time this is cosine phi is equal to 0. Transfer FBC. This is FAC is equal to FBC cosine phi is equal, this is equal to, substitute the value, 8.9442791, and this is cosine of 26.56505117708. So FAC is equal to, answer times cosine 26.56 50511 7708, and the answer is 8 kilonewtons. Box your final answer. So after having calculated AC, we can now solve for AB, right? How to do that? So now, if you can notice again, using the equilibrium of a rigid body analysis, for our case, for this one, take note that for our B here, this is hinge. That meaning it can resist. Oh, it's not clear. We can say, just use black. Can resist X or vertical and horizontal forces. Again, these two are just assumed. The sense of our BX and BY is just assumed. And then for our A, it can also resist a horizontal component. Now, if you can notice, if we saw these two solved already, right? Now, if we try to solve for B here, take note that AB also is still unknown. So meaning if we do force summation along x and along y, we will end up with 3 unknowns. So we don't do that because we cannot solve 3 unknowns using just 2 equations. So we will proceed with point A here. So at A, so if you try to go back, this is AC, AB, and AX. Okay, so we assume this is the direction of AX. We also assume that this is the direction of force AB, and then we assume that no, not assume, because we're able to get AC. Now AC here is compressioning towards the point, so we have to stay consistent. So therefore this is also force AC. Okay, now summation of forces x is equal to 0, assuming to the right positive. So this is AX minus FAC is equal to 0. AX is equal to FAC, therefore A sub X is equal to 8 kilonewtons. Okay? Next, from this, box your final answer again. From here, we can say that summation of forces y is equal to 0, assuming going up positive. So this is FAB is equal to 0. Okay, now, having calculated AB, we can now solve for our BX and BY. So at B, we assume AB is tensile, right? So let's say force AB. Now, for our BC is tensile, right? With value of 8.944279191 kilonewtons. So tensile, so away. This is force AC. Let me just erase AB first. This is force AB. Right? Now, since there are 2 forces involved already, but of course, since AB is 0, so we have to resist AC only. Now, for AC, take note that AC is going to the right. Therefore, by inspection, we can say BX is to the left and AC is going down, so BY should be going up. Now, here, this is theta. No, this is phi. Let's say the angle between AB and BC is theta, and theta is 90 degrees minus phi. Okay, so we say this is theta. Now we can say summation of forces x is equal to 0, assuming going to the right positive. So this is FAC, and that is sine theta minus BX is equal to 0. BX is equal to FAC sine theta, wherein FAC is how much is here? AC? Oh no, is it AC? That's BC. Sorry, this is B. This is BC. This is BC sine. Okay, this is also BC here. BC. Now the value of BC, I think this is it's available here. This one, right? That's 8.944. Okay, this is parenthesis 8.9442791, and sine theta. Theta is, we just have to copy this one, copy as text, then here all, put it here, paste, and then sine answer. No. It should be 90 minus answer. That's 63. Sine answer. No. So this is 63.434,948,8229. Then bx is, you multiply that by times 8.94427,191. bx is 8 kilonewtons. And lastly, summation of forces y is equal to 0, assuming going up positive. So this is by minus fbc. fbc here is cosine theta, cosine theta minus also fab. FAB is equal to 0. So therefore, BY is equal to FBC cosine theta plus FAB. FBC is 8.94427,191 cosine 63.43494882229 plus AB is 0. So B sub Y is equal to, we have 8.94427,191 cosine 63.43494882229. BY is 4 kilonewtons. Now, our four answers, the reactions Bx, By, and the 8 kilonewton Ax can be checked using moments. Now take note, what we did here was solve by joints. Now if you are just going to solve it as a whole structure, so we have, I'm going to say alternate solution for the support reactions. So this is our triangle, right? We have four kilonewtons, and then we say this is uh, bx here, then by, and then we have ax here. Okay, so what we can do here is do moment. Let's say at a, therefore moment about a is equal, the sum of all moments about a is equal to 0, assuming counterclockwise positive. So for this case, this is bx multiplied by the perpendicular distance 2. This is 2, and then minus 4 kilonewtons, and then the perpendicular distance of 4 kilonewtons is 4 meters. So 4 is equal to 0. No b sub y, because b sub y and a sub x, their line of action passes through point A. This is point A and this is point B. Okay, so therefore this is b sub x is equal to 16 over 2. Therefore b sub x is equal to 8 kilonewtons, which is the same with what we got using the method of joints. Another is, we can also say force summation. We have moment summation. Moment at B is equal to 0, assuming counterclockwise positive. So for this case, we can say a sub x is counterclockwise. So this is a sub x. The perpendicular distance again is 2. Then 4 is clockwise. 4 times perpendicular distance of 4 kilonewtons from A is also 4, is equal to 0. So that A sub x is equal to 16 over 2. A sub x is equal to 8 kilonewton, which is again the same with what we got here. And then for our B sub by 4 kilonewton, we simply say summation of forces y is equal to 0, assuming going up positive. Now for this structure, there are only two vertical forces, and that is b sub y going up and 4 kilonewton going down. So this is b sub y is equal to 4 kilonewtons. Thank you.